Concept of battery. Okay, so what is a battery? What is its function in a circuit? And what happens, more importantly, what happens inside the battery? Okay, so we are interested in that. So this is how you represent a cell in a circuit. So a single unit is called as cell. I'm sure all of you know this already. A single unit is called as a cell, and multiple units connected in a circuit is known as battery. Okay, so cell is the singular name, and battery is the plural. Clear? So why one of this line, one terminal is taller and one is short? Because that is just differentiation between the positive and negative terminal. The shorter one is negative and the taller line is the positive terminal. Okay, so that is just a convention. So what happens inside a cell? What is the function of cell in a circuit? To maintain potential difference across its terminals. Okay, so in a circuit, for an electron to flow from one point to another point, you need potential difference. Just like water require a height difference. Water cannot flow from the same height from a point to another point. If both are at the same height, then water cannot flow. Water can only flow from a higher height to lower height. Similarly, electrons require potential difference in a circuit to travel from one point to another point. Okay. So what happens inside a battery? So the chemical part of it, the chemistry or the chemical reactions occurring inside the cell that you learn in chemistry, right, with the different chemicals, different compounds, different molecules. I'm sure you have learned it in chemistry. And that is the reason why electrons are able to travel from one terminal to another terminal. Okay, and we call that force due to battery mechanism. Okay, here it is represented by FB. Force due to battery mechanism. So this force is not due to electrostatics. It is not an electrostatic force. It is due to the chemistry happening inside the battery. Okay, so I'm sure you have learned it in chemistry. So electrons will be able to travel from one terminal to another terminal. Clear? So here you can see if it is connected in a circuit. If the cell is connected in a circuit, then we know the direction of current. We know the direction of current is going to be this. This is the direction of current, and electrons are traveling. Electrons are traveling from initially. Suppose initially you are just starting this. Initially there were no flow of electrons or anything. Okay. Initially, suppose imagine just the battery cell. Imagine only the cell, and the chemical reactions have started. Okay. So electrons are moving from one plate to another plate, and there is this battery mechanism. There is this force due to battery mechanism, FB acting between the plates. Okay, and that is in this direction. That will help the charges to move from one plate to another plate. Also, after some time, you can see one of the plate is negative and the other plate is positive. Okay, so electrons are accumulated here, and positive charges are on the positive terminal. Okay, and you know when you connect this in a circuit, you know the direction of current is going to be like this. We have defined the direction of current from positive terminal to negative terminal, and the flow of electrons is in the opposite direction, right? Flow of electrons is in the opposite direction. So that we already know, we have already discussed that. So here what we need to understand is the function of a cell or a battery is to provide potential difference in a circuit. Also, inside the battery, inside the cell, there is a non-electrostatic force called FB, which is due to the battery mechanism. That is what helping the charges to move from one terminal to another terminal. Okay, clear? So I hope that is clear. So inside you can see electrons will be moving from positive plate to negative plate. Inside the electrons will be moving from positive plate to negative plate due to the action of FB. And after some time, after this separation has occurred, after many positive charges and negative charges are segregated, and there will be an electric field. An electric field will also be formed here. You can see an electric field will also be formed here. And as a result of that electric field, now these charges will be experiencing an electrostatic force also. There is already a force due to the battery mechanism, and due to this separation, after enough number of charges have separated, the electric force or electrostatic field between these plates will increase. Slowly it will increase, and we call a state called steady state. At steady state, the force due to battery mechanism would be equal to the force due to this newly formed electric field. That is represented here using FB is equal to FE. When FB is equal to FE, when it becomes QE, we call this as steady state. We call it as steady state. Okay. So these are what happens inside a cell. A cell is able to provide a constant potential difference in a circuit so that electrons can flow continuously to provide us electric current. Okay. And the reason who is driving these electrons, to travel from one plate to another, it is the force due to battery mechanism. Okay, force due to battery mechanism. And here, if you were to calculate the work done, by this force due to battery mechanism, then we can say if the distance of separation is d, then the work done will be equal to FB into d. Right, at steady state it will be equal to QE into d. At steady state it is equal to QE into d because FB is equal to QE at steady state. Okay, so that is QED, or we can say E into d is potential difference. That we learned in electrostatics chapter, right? Electric field into the distance is equal to the potential difference in that area. That we learned in electrostatics. So QED, or we can say QV. Okay. So what is WB? It is the work done by the battery in moving Q charge between the terminals. Work done by the battery in moving Q charge between the terminals. And V is the potential difference between the terminals. Okay. So we will summarize again the concept of a battery. So the role of a battery, or the function of a battery, is to provide potential difference in a circuit so that electrons can flow continuously, just like water flowing from a higher height to lower height. Very easy to understand. And who is driving these charges to move from one point to another? Who is providing that force? It is the battery mechanism. The chemistry or the chemical reactions about it, you will learn. You have already learned it in chemistry. Okay, so we don't have to worry about that. And once this motion starts going, once this electron starts moving from one plate to another plate, there will be a steady state. So how a steady state is achieved? Due to the segregation of charges, due to the separation of charges, an electric field will be formed between the cell, which is in the opposite direction of the force due to battery mechanism. And when those two forces are equal, they are already opposite. When those two becomes equal, we will have a steady state. Okay. And even in steady state also, the battery will provide potential difference. It will provide potential difference. Okay. And that potential, and what is the potential difference? How much is that potential difference? Well, at steady state, if you want to move this electron, from one plate to another plate, then the force applied should be equal to QE into D. And that E into D is V. And we can say work done is equal to work done by the battery to move this electron or this charge from one plate to another plate is equal to Q into V. Right? We have learned in electrostatics that the work done by a charge, work done on a charge to move through a potential difference of V is equal to Q into V. Therefore, the battery is actually moving these charges across a potential difference of capital V. Okay, so this is how we can relate to the potential difference across the terminals of a battery. Okay, so I hope that was not too complicated. It is very simple to understand. You can just imagine electrons moving between these two plates under the action of battery mechanism. Okay, and battery and EMF. And what is EMF? EMF is the work done. The full form of EMF is electromotive force. Electromotive force. EMF is the work done by the battery per unit charge. So in the previous, we wrote WB is equal to Q into V. Therefore, V is equal to WB by Q. Right? That is EMF. Even though the name is force, it is not a force. It is work done per unit charge or electric potential. EMF of a cell is electric potential. Nothing but electric potential. It is not a force. Okay. EMF of a battery is potential difference between its when terminals are not connected externally. EMF of a battery is potential difference between its terminals when terminals are not connected externally. It means they are just kept like this. They are not connected to any external components. So this is now in a steady state. This is now in a steady state, and there is a potential difference between these plates that we have explained clearly in the previous slide. Okay, so in this situation, when it is not connected to any outside components, the potential difference between those terminals is equal to EMF of that cell. So when you buy a battery, most common when you buy a AA battery of EMF 1.5 volt, the meaning is the maximum potential difference between the terminals is 1.5 volt. That is the meaning of it. Okay, what is EMF? EMF is the maximum potential difference across the terminals of a battery. We buy batteries from shops. Most common one is 1.5 volt that we use in many devices, right? So that is 1.5 volt. And what happens when you connect it in a circuit? When you connect this in a circuit, when you connect this in a circuit, then the potential difference across the cell is not going to be equal to EMF. It is not going to be equal to EMF. Okay, and the reason is current will start flowing and there will be potential drop across resistors and other components. Okay, there will be potential drop across resistors and other components, and as a result you will not be getting the EMF across the terminals when you connect it in an external circuit. Okay, so when you keep the battery alone without connection to the external components, then the voltage across the terminals is known as the EMF, electromotive force. So why we call it as a force even though it is not a force? It's because that is the driving force. Okay, not literally, not technically it is a force, but it is the driving force that takes electrons from one point to another point. So that is why we call it as electromotive force even though it is electric potential or work done per unit charge. Okay, so here V is the potential difference across terminals, E is the electromotive force or EMF, and FB is the non-electrostatic force of battery that we already explained. So this is the theory of a cell. This is the concept of battery. What happens inside it? What is EMF? What is potential difference? Potential difference is the general value. It can be calculated at any time. Okay, even if it is not connected to battery, even if it is connected to external components, we can define potential difference. But EMF is the maximum value. And when will you get the maximum value? When you have not connected the cell to any components. Okay, what happens if you connect it to components? Current will start flowing, and as a result there will be potential loss. There will be potential drops across the components, and you will not be able to get the maximum value when you measure potential difference across the terminals. Okay, clear? Now one more thing about internal resistance. One more thing about battery is the internal resistance of a battery. So when electrons are moving inside the cell, it will encounter many resistances because there is a lot of materials inside the cell. There are a lot of chemical components inside the chemical molecules and compounds inside the cell, and as a result, during this motion of electrons, it will collide with other molecules, other ions, etc., other electrons. So the same idea of resistance comes here also. The traveling of electron between the cells, between the terminals, there will be some resistance, and that resistance is known as internal resistance of a cell. Okay, internal resistance of a cell, resistance offered by the conductor placed inside the battery. Okay, the conducting material, whatever material it is placed inside the battery, will have some resistance. That is known as internal resistance of a battery. And the way we represent it is, we draw a resistance very close to the cell. In circuits, we draw a resistance close to the cell, and we use the small letter R to represent internal resistance. This is the EMF, and that is the internal resistance of the cell. Okay, so I hope you got the idea of a cell, and in the coming class we have a lot more to learn about cells. What happens when you connect multiple cells in series, in parallel, etc. Okay, so this basic idea of cell is very important, what happens inside it, and more importantly, what is EMF and the difference between EMF and potential difference across its terminal. Okay, So we'll continue the next class, and we'll start from here and go to the connections or other complicated things about cells. Okay, goodbye.